Okay, number 7, VLI 7. So this is a matter of parameterizing the curve and plugging into the formula, right? And so the trickiest part of this problem is parameterizing the curve. So let's try to draw a picture of it. We've got this cylinder x squared plus y squared equals 4. And of course that's a cylinder centered on the z-axis, kind of like this. Draw it down here like that. And now we've got a plane cutting through there. Let's see, x minus y plus z. So there's some plane. It's going to be hard to draw, but there's a plane sort of cutting through, maybe sort of like this. And as it cuts through, it makes an ellipse like that. Does that make sense? This is our curve. And let's see, moving clockwise as seen from above. Okay, clockwise as seen from up here, clockwise, so kind of like that. Okay. So how do you parameterize this? Well, now a piece of good news. While parameterizing this thing might be a little bit hard, its projection down into the xy plane is not hard. Because I know what its projection in the xy plane is just this circle. It's a circle in the xy plane, radius 2, centered at the origin. So that projection, notice that the x and y coordinates of a point on the curve I'm interested in are exactly the same as the x and y coordinates of a point on that easy to parameterize circle in the xy plane. So let's see, I needed to go clockwise around like that. So the usual cosine sine goes counterclockwise. So I could I could make it go the other way by saying cosine, let's see, well, 2, of course, because of the radius. 2 cosine t, and then I'll say negative 2 sine t. And that'll start here, and instead of starting off that way, it'll just start off going that way. Right, so I claim this parameterizes that circle in the xy plane. Let me pause there for a second. Does that make sense?
So you just had to, can you explain why you had to reverse the direction?
Yeah, because the problem says that I want this, on this ellipse, I want it going around that way. That's clockwise as seen from above. Right? And so its projection also is going to be going clockwise as seen from above. And when you do cosine comma sine, that's just going counterclockwise. Okay. So you put a minus sign there, and then instead of going that way to start, it goes that way to start. Yeah. Yeah.
Could you also do that by calling y2 sine t and then setting your domain from like 0 to 2 pi?
Say that again?
Or from 0 to negative 2 pi.
Yeah, that's another thing you can do. That'll work. That'll totally work. Yeah, no problem. Yeah, I'm going to do it this way whatever. Okay, so that's the x and the y. Now, of course, that's not a complete parameterization. I've got to know what the z-coordinate is doing. The z-coordinate's kind of going up and down as we go around this thing. And conveniently, though, I can just solve for z in the equation of this plane. Z has to be 3 minus x plus y. And x and y I've already decided on. So z has to be 3 minus x plus y. Oops, well, y has a minus on it, so minus 2 sine t. So there's what z has to be as a consequence. Does that make sense? So now you got x, y, and z. We want to compute the line integral around this curve. We've got a vector field dot dx. So I'm going to need to compute x prime. That's algebra. Let me rewrite this. I've got f dot x prime dt. T, let's see, I need this to go around once. So t goes from 0 to 2 pi. This is all functions of t that you can calculate, and this is algebra at this point. Is that okay? Okay. Okay, cool. All right, anybody else? Any other questions on this problem? Okay, let me stop the recording here.